The weapon's sheer weight, 122 pounds with tripod, was another liability, over twice that of the M1919 system. Precision machining added reliability in controlled conditions, but became a fatal vulnerability in the mud, sand, and debris of Pacific battlefields. Each Type 92 included an internal oiling mechanism to lubricate cartridges, intended to smooth extraction. In practice, the oil collected dust and grit, causing jams at the worst possible moments. Even minor contamination could halt operation entirely, a problem the M1919's looser tolerances avoided. The feeding system was fragile and cumbersome. Metal strips could bend or fail, and reloading required precious seconds in which the gun could not fire. American gunners, in contrast, could link multiple cloth belts, creating nearly uninterrupted feeds of 500 rounds or more. The Type 92's offset sight, located to the right rather than aligned with the barrel, further complicated rapid engagement and reduced practical accuracy under combat stress. In short, the battle on Red Beach 2 revealed the practical consequences of these design differences. American crews with the M1919 delivered continuous, reliable, and high-volume fire, enabling them to suppress waves of Japanese attackers. Type 92 crews, despite firing a heavier cartridge, were hampered by their guns' weight, complex maintenance requirements, and limited feed capacity. The difference was not theoretical. It was measurable in casualties, territory gained, and the ability to maintain fire under pressure. Between 1932 and 1945, Japan produced roughly 45,000 Type 92 heavy machine guns. Manufacturing was concentrated in firms such as Tokyo Gas and Electric, Henino Motors, and Hitachi, all of which adhered to meticulous peacetime standards that proved incompatible with wartime urgency. Each Type 92 required extensive hand fitting, making the weapons expensive, slow to produce, and labor-intensive. By contrast, American industry was capable of mass-producing the M1919 Browning on a scale unmatched by Japan. During World War II alone, the United States manufactured nearly 390,000 M1919s, almost 9 times Japan's total Type 92 output. This disparity highlighted the profound difference in industrial capacity between the two nations. The American production philosophy emphasized standardization and interchangeability. Using assembly line techniques refined in automobile manufacturing, factories such as General Motors' Saginaw Steering Gear Division produced fully interchangeable parts. A Browning made at Rock Island Arsenal could seamlessly accept components from Saginaw or Buffalo Arms. Japanese Type 92s, by contrast, often required individualized fitting of spare parts, since components were crafted by hand, meaning parts from one weapon might not work in another. By 1944, American factories were producing more M1919s in a single month than Japan could manufacture Type 92s in an entire year.
The operational implications of this industrial advantage were made painfully clear at Henderson Field, Guadalcanal, on the night of October 24, 25, 1942. Sergeant John Basilone, awarded the Medal of Honor for his heroism with the water-cooled M1917, witnessed the advantages of the lighter, air-cooled M1919A4 firsthand. Throughout the perimeter, Marine gunners could quickly reposition these weapons to respond to Japanese attacks, a mobility that the heavier stationary water-cooled guns could not match. Private First Class Mitchell Page, also a Medal of Honor recipient that night, described the tactical flexibility the M1919 afforded. The air-cooled machine guns served as a mobile reserve, allowing crews to move swiftly to gaps in the line and provide immediate suppressive fire. The Japanese attackers, burdened with heavier weapons, could not match this responsiveness. The M1919's reliability was equally evident during amphibious assaults. At Tarawa in November 1943, Marines landed on coral-strewn beaches, often soaked in seawater. Despite these harsh conditions, M1919 crews rapidly deployed their weapons and began firing. Corporal James Russell of the 2nd Marine Division recounted advancing his M1919A4 by hand across the battlefield, using water from canteens to cool the barrel and brushing sand off belts, yet never experiencing a stoppage. Over 2,500 rounds were fired from his gun without a single malfunction. In stark contrast, Japanese Type 92s on Betio Island were plagued by constant failures. Coral dust and grit fouled the oiling system, and the intricate, precision-fitted parts made the weapon vulnerable to the environmental conditions of the Pacific. The Battle of Saipan, June-July 1944, further demonstrated the overwhelming advantages of American machine gun doctrine. During a massive banzai assault on July 7th, 4,000 Japanese soldiers advanced against entrenched positions of the 27th Infantry Division. M1919 crews created overlapping fields of fire that transformed the charge into a devastating slaughter. Sergeant Thomas Baker's crew maintained continuous fire for 6 hours, cycling spare barrels when overheating occurred. His assistant, Carl Morrison, later recalled that their single gun accounted for perhaps 200 enemy casualties. In Peleliu in September 1944, the M1919's resilience under extreme conditions became legendary. Marines endured temperatures exceeding 115 degrees Fahrenheit, where Japanese Type 92s frequently jammed due to thermal expansion in their precisely machined components. The Browning, with its looser tolerances and robust construction, continued firing without interruption, demonstrating the weapon's adaptability to both environmental stress and sustained combat.
Across multiple Pacific campaigns, the combination of American industrial capacity, practical design philosophy, and the M1919's mechanical reliability consistently delivered decisive firepower. Where Japanese Type 92s faltered due to complexity, weight, and susceptibility to contamination, the M1919 proved flexible, mobile, and unyielding, a critical factor in the success of Marine and Army operations across the Pacific theater. During the Battle of Manila in February 1945, the tactical significance of mobility in urban warfare became evident. Marine and Army units equipped with the M1919 Browning could quickly relocate their weapons from one building to another, firing through windows or doorways while maintaining continuous suppression. Weighing approximately 45 pounds with tripod, the system could be carried and deployed by a 2-person crew, providing remarkable operational flexibility. In contrast, Japanese Type 92 crews, burdened with a weapon system weighing 122 pounds, were effectively immobilized once deployed, making them vulnerable in dynamic urban combat. Lieutenant Colonel John Chasen noted that the ability to fire and move simultaneously was critical in city fighting, a capability American crews exploited repeatedly while Japanese gunners remained fixed targets. The M1919's design and evolution reflected lessons learned from World War I and extensive interwar testing. The original M1917 water-cooled Browning had proven highly effective in Europe, but the U.S. Army identified a need for a lighter, more mobile automatic weapon for future mechanized and expeditionary warfare. By 1919, John Moses Browning had converted the design to air cooling, producing a weapon that could be mounted on vehicles, aircraft, or used by infantry. Over the next 2 decades, the Ordnance Department refined the design systematically, incorporating field feedback from testing, improving barrels, simplifying feed mechanisms, and lowering tripod profiles. The standardized 30-06 Springfield cartridge, in service since 1906, ensured reliability, sufficient range, and stopping power for modern combat. By contrast, the Japanese Type 92 represented an attempt to adapt older foreign technology without fully appreciating the demands of high-volume, sustained fire in modern warfare. Based on the French Hotchkiss machine gun, licensed in 1905, the Type 92 incorporated features that ultimately reduced effectiveness in Pacific combat. Japanese military experience, largely shaped by campaigns in China against poorly armed opponents, had conditioned crews to rely on precise single shots and short bursts, a tactic that proved inadequate against well-armed U.S. forces. Japan's emphasis on precision craftsmanship, rooted in centuries of samurai tradition, prioritized meticulous hand-fitting over mass production. Each Type 92 was individually built, requiring careful attention to component alignment,
which slowed output and complicated repairs. An internal cartridge oiling system intended to ensure smooth extraction instead attracted sand, coral dust, and humidity, causing frequent malfunctions in the field. The 30-round metallic feed strips were fragile, easily bent, and limited sustained fire capability, leaving crews exposed during reloads. Reports and personal accounts from Japanese soldiers underscore the operational consequences. A diary recovered from Saipan observed that American machine guns fire continuously without pause. Our Type 92 stopped to reload every 30 rounds. One enemy gun achieves the effect of 5 of ours. A report from Guadalcanal similarly stated that U.S. automatic weapons produced a solid wall of bullets, describing the M1919's continuous fire as a mechanical, unescapable force. American gunners were nicknamed the lawnmowers by Japanese troops for their lethal efficiency of their suppressive fire.
Lieutenant Hiroaki Samashima, captured on Luzon, detailed the technical shortcomings. The Type 92's oil system became adhesive in jungle humidity, mixing with dirt and plant matter, and crews spent more time clearing jams than engaging the enemy. Each 30-round strip required constant replacement, during which U.S. gunners could neutralize entire squads. Soldiers nicknamed the M1919 Hitler's Zipper because of its unrelenting, terrifying rat-a-tat fire, a stark contrast to the intermittent chatter of the Type 92. Japanese post-war analyses, including documents discovered at Kure Naval Base, concluded that the Type 92 could not compete with American firepower. Recommendations for improvements were largely impractical due to production constraints. Commanders were forced to rely on courage and initiative to offset mechanical inferiority. Across multiple campaigns, this technological disadvantage repeatedly dictated the outcome of engagements, emphasizing that in modern combat, industrial capacity and weapon reliability could decisively outweigh bravery and training alone. Throughout World War II, American production of the M1919 Browning maintained remarkably high standards, even as output scaled from a few hundred to thousands of weapons per month. Interchangeability was a cornerstone of this system. Parts manufactured at the Saginaw Division of General Motors fit seamlessly into guns produced by Buffalo Arms or Rock Island Arsenal, allowing field repairs to use components from any source or even cannibalized weapons. Quality control remained rigorous, enforced through statistical inspections and strict adherence to design specifications. The simplified assembly line production processes developed for mass manufacture paradoxically enhanced reliability. By eliminating unnecessary complexity and increasing tolerances, the M1919 became more resilient under combat conditions. At Saginaw, workers trained in automotive assembly, previously building steering columns, were retrained to produce machine guns. The factory employed specialized machinery, division of labor, and tightly organized assembly line methods. Each worker repeatedly executed specific operations, producing guns with uniformity and speed unattainable through handcrafting. By 1943, Saginaw alone was producing 10,000 M1919s per month, a rate surpassing Japan's entire annual Type 92 output. Japanese production of the Type 92, in contrast, suffered as the war progressed. Early models produced by Tokyo Gas and Electric exhibited fine craftsmanship, with smooth blued finishes and carefully fitted components reflecting the company's peacetime experience in industrial equipment. By 1944, wartime pressures forced shortcuts. Rough machining, simplified sights, and declining metallurgy became evident. As resources dwindled, inferior materials, cast iron replacing steel, wooden handles replacing metal, and weak feed strip guides were used, undermining reliability. The gun's intricate oil pump system, originally designed to lubricate cartridges for smoother extraction, grew even more problematic as production quality deteriorated. Late-war pumps either over-lubricated, attracting dust and debris, or under-lubricated, causing frequent jamming and extraction failures. Captured Type 92s from 1945 were often rendered inoperable without complete rebuilding. Even Japan's own inspections rejected an increasing proportion of newly produced guns, but desperation compelled commanders to send substandard weapons to frontline units. Meanwhile,
American forces benefited from uninterrupted, perfectly standardized ammunition. Whether manufactured in Denver, St. Louis, Salt Lake City, or other facilities, every .30-06 Springfield round functioned reliably in any M1919. Supplies were shipped in moisture-proof containers, preventing the corrosion and degradation that plagued Japanese ammunition in the tropical Pacific. By 1944, U.S. factories were producing over 10 billion rounds annually, ensuring continuous operation for every machine gun in the theater.
Ongoing innovation expanded the M1919's combat versatility. Armor-piercing M2 rounds could penetrate reinforced Japanese bunkers and lightly armored aircraft, while a variety of tracer rounds enabled night operations. Standard tracers for a target designation, dim tracers for covert firing, and delayed tracers that ignited only after traveling 100 yards, reducing shooter exposure. Incendiary ammunition was deployed against fuel storage and aircraft, and armor-piercing incendiary (API) rounds combined penetration and ignition capability, demonstrating the adaptability of American munitions in diverse combat conditions. By contrast, the combination of declining production quality, overly complex design, and limited ammunition supply meant that Japanese Type 92 crews were consistently outmatched. The contrast between the two nations' machine gun systems exemplified the broader industrial and technological imbalance that determined the outcome of Pacific engagements. American mass production and standardized versatile weapons consistently outperformed Japanese precision engineering, hampered by resource scarcity and wartime pressures. The M1919A6 variant, introduced in late 1943, represented an effort to increase mobility for infantry machine guns. It incorporated a shoulder stock, carrying handle, and bipod, enabling Marines to maneuver the weapon more effectively despite its 32-pound weight, not including the tripod. While still heavier than ideal for a fully portable light machine gun, it offered American units enhanced flexibility on the battlefield. In the field, Marines adapted the M1919 to meet operational demands. One notable innovation, the Basilone Bale, was a wire and wood handle designed to allow the barrel to be moved even when hot. Conceived by John Basilone based on his experience at Guadalcanal, it was later standardized for production. Marines also experimented with mobile firing setups, including crude hip mounts for advancing fire, though these proved largely impractical. More effective were improvised anti-aircraft configurations assembled from salvaged materials, allowing the M1919 to target low-flying Japanese planes. Tank crews sometimes welded additional guns externally to provide suppressive fire against infantry attacks. The simplicity of the weapon's design meant such modifications could be executed with basic tools and minimal technical training. In contrast, Japan struggled to provide sufficient 7.7mm ammunition for the Type 92. The semi-rimmed cartridge required precise manufacturing, which became increasingly difficult as Allied submarines disrupted shipping and B-29 bombers destroyed factories. Japanese ammunition came in at least 4 non-interchangeable variants, creating complex logistical challenges. The 30-round feed strips were fragile, prone to bending and susceptible to rust in humid conditions. Unlike the American M1919's cloth belts, which could be linked to create nearly limitless continuous feeds, Type 92 strips were single-use and highly failure-prone. Furthermore, the weapon itself saw virtually no evolution from Guadalcanal in 1942 to the war's final battles in 1945. Critical issues such as the cumbersome oil pump, limited feed system, and excessive weight remained unaddressed. Even minor enhancements such as adding water drainage holes or enlarging trigger guards for gloved hands were never implemented, as Japanese industry could not accommodate the tooling and re-engineering required. American gunners, by contrast, received extensive training before deployment. The M1919's operation was straightforward: pull the bolt handle twice, feed the belt, and squeeze the trigger. Barrel changes could be executed quickly with minimal protection, using asbestos mitts, while the top cover opened easily for maintenance. U.S. doctrines stressed sustained fire, mobility, and teamwork. Crews were trained in assistant gunner support, belt handling, and barrel cooling, while practicing jam clearing until responses were instinctive. Range estimation, traverse and elevation adjustments, and understanding beaten zones became automatic skills. Most crucially, crews were drilled to shoot and displace rapidly, firing controlled bursts and relocating before enemy mortars could target them. The 45-pound weapon system allowed a two-person team to lift and run, preserving firepower while remaining mobile.
Tactically, American doctrine leveraged overlapping fields of fire. Guns were positioned to cover each other, ensuring continuous suppression. If one weapon required maintenance or jammed, adjacent crews increased their rate of fire to maintain dominance. The result was an amplified effect of each individual gun, turning small teams into potent killing units. By contrast, Japanese Type 92 crews faced complex and fragile systems. The oil pump required precise adjustment for humidity and temperature. Too much oil in the cold could congeal. Too little in heat caused jams. Feed strips had to be handled carefully to avoid bending. Sights demanded constant recalibration for different ammunition types. Japanese doctrine prioritized accuracy over volume, training crews to fire deliberate, short bursts at chosen targets. With limited ammunition and slow reload times, this approach made tactical sense in theory but failed against American firepower. While a Type 92 crew aimed carefully at an individual Marine, multiple M1919s could saturate the position with lethal, continuous fire, obliterating defenders before they could respond. This contrast highlights a fundamental difference in military philosophy. American weapons, training, and doctrine emphasized sustained fire and adaptability, while Japanese systems relied on precision, conservation, and static defense. On Pacific battlefields from Guadalcanal to Iwo Jima, this divergence consistently favored American units, demonstrating that in modern warfare, rate of fire, reliability, and operational flexibility often outweighed individual marksmanship or courage. The M1919 Browning earned a reputation for extraordinary reliability among American forces in the Pacific. Veterans recounted instances where the weapon continued to function after being submerged in seawater, buried under coral dust, or coated in volcanic ash during the battles on Eniwetok and Iwo Jima. The design's relatively loose tolerances, which some critics argued reduced precision, in fact enabled the gun to operate in adverse conditions that would disable more finely fitted weapons. Marines frequently reported firing the M1919 continuously for hours, using water from canteens to cool the barrel and maintain a steady rate of fire. On Okinawa, one gun was blown off a cliff by shell fire, tumbling 30 feet onto rocks. Yet after replacing the bent tripod, it returned to action for the remainder of the engagement. Another M1919 retrieved from a swamp on Guam after 3 days of submersion resumed firing effectively after minimal cleaning. Such verified reports reinforce confidence among crews, who trusted that their weapons would function under any circumstance. The gun's simplicity was central to its dependability. With only a few moving parts, the bolt, barrel, and feed mechanism, malfunctions were rare. Its recoil-operated action allowed cycling to continue as long as ammunition was available. Even heavily worn weapons with excessive headspace remained functional, though accuracy could decline. Field maintenance required only basic cleaning and lubrication, which could be improvised with motor oil, cooking oil, or even coconut oil when conventional supplies were unavailable. By contrast, the Japanese Type 92 heavy machine gun was notoriously unreliable. Marines quickly learned to recognize the silence that indicated a jam and would use these opportunities to advance or reposition. The weapon's internal oiling system, intended to ensure smooth operation, became its greatest vulnerability. In the humid jungles of Guadalcanal and New Guinea, oil combined with moisture and plant debris to form a sticky paste that immobilized the mechanism. On coral at Tarawa and Peleliu, fine sand mixed with the lubricant, creating an abrasive compound that quickly wore down the precisely machined parts. Captured Type 92s required extensive cleaning just to fire. Even when properly maintained, constant attention was necessary to keep them operational. Feed strips rusted in humid conditions, binding together and preventing ammunition from feeding, while the oil pump clogged with debris, sometimes necessitating complete disassembly. Thermal expansion in tropical heat caused the finely fitted components to seize. American intelligence concluded that Type 92 maintenance demanded 5 times the labor required to keep an M1919 operational.
The Battle of Okinawa from April to June 1945 offered the most extreme test of these weapons' capabilities. American forces, having refined machine gun tactics through years of combat, employed coordinated crews to create overlapping fields of fire that made frontal assaults virtually impossible. During the massive Japanese counterattack on May 4, 1945, M1919 teams faced waves of soldiers attacking in coordinated formations. Crews from the 96th Infantry Division fired relentlessly for more than 12 hours. Staff Sergeant Beaufort Anderson's section expended 30,000 rounds in a single night, rotating through 6 spare barrels without ever experiencing a stoppage. Anderson later recalled that bodies accumulated so densely in front of their position that firing continued through them, with the weapon performing flawlessly under extreme conditions. Japanese Type 92 crews displayed remarkable courage, but their equipment fundamentally limited their effectiveness. The 30-round feed strips were rapidly expended during intense firefights, forcing gunners to pause for reloading while under lethal return fire. Even when these weapons successfully struck American positions, the effect was negligible compared to the overwhelming and continuous fire delivered by M1919s. American machine guns could sweep entire areas, neutralizing enemy forces in seconds, while Type 92s were constrained by their design, unable to sustain suppressive fire or match the firepower needed to resist modern infantry tactics. This contrast between the M1919 and Type 92 illustrates a broader truth of the Pacific War. Mechanical reliability, operational simplicity, and high-volume firepower frequently outweighed skill, bravery, or individual marksmanship. The Americans' combination of robust design, standardized production, and tactical doctrine gave them a decisive advantage, one that repeatedly proved fatal for Japanese defenders relying on precision craftsmanship over adaptability and sustained fire. The intense cave and tunnel combat that defined much of the Okinawa campaign further highlighted the advantages of the M1919. Its relatively lightweight and portability allowed U.S. Marine and Army units to bring machine guns deep into complex cave networks, enabling sustained fire in confined and otherwise inaccessible positions. Japanese Type 92 heavy machine guns weighed 122 pounds with mount and tripod, rendering them effectively immobile in such environments. After-action reports consistently noted abandoned Type 92s in caves, often surrounded by broken or jammed feed strips, a testament to crews who had been forced to leave their weapons behind when positions were overrun. One striking statistic underscores the disparity. During the Okinawa campaign, American forces captured over 200 Type 92s, yet fewer than a dozen were functional. The remainder had been disabled by their crews, abandoned due to repeated malfunctions, or were simply too worn to be repaired. In contrast, M1919s that had seen continuous service since Guadalcanal remained operational, illustrating the durability and reliability of American design and production.
By war's end, the scale of manufacturing further highlighted the imbalance. The United States had produced nearly 390,000 M1919 machine guns across all variants, while Japan's total Type 92 output barely exceeded 45,000 units. This nearly 9-to-1 advantage in automatic weapons gave U.S. forces a decisive edge. Americans could sustain high rates of fire without concern for resupply, whereas Japanese crews were forced to conserve ammunition, knowing replenishment was increasingly impossible. The M1919's influence extended well beyond World War II. The weapon continued in U.S. service through Korea, Vietnam, and various other conflicts, with Allied nations maintaining it into the 1990s. Some examples were even converted to fire 7.62 by 51 mm NATO, remaining operational decades after their initial manufacture. Its belt-fed system and quick-change barrel, innovations perfected in the Pacific, became standard features in subsequent designs, including the M60, which directly inherited many of Browning's principles. Despite its shortcomings, the Type 92 earned a measure of respect for the bravery of its crews.
Captured examples became coveted artifacts among American soldiers who demonstrated their complex feed mechanisms and cumbersome operation at Bonn rallies and military exhibitions, emphasizing the contrast with the straightforward and reliable M1919. Ironically, many of these captured Type 92s have survived in better condition in private collections than they ever did on the battlefield, meticulously maintained by enthusiasts who could devote the constant care these guns demanded. Post-war U.S. ordnance evaluations revealed the fundamental flaws of the Type 92. Tests conducted at Aberdeen Proving Ground showed that even under ideal conditions with meticulous maintenance, the weapon could not sustain rates of fire comparable to the M1919. The oiling system, intended to ease cartridge extraction, proved incompatible with real-world combat conditions, while the 30-round feed strips were cumbersome and fragile. The weapon's extreme weight made repositioning slow or impossible, further reducing its tactical utility. Analysts concluded that the Type 92 was effectively a peacetime design, incapable of meeting the demands of modern warfare.
The philosophy underpinning American wartime production extended across every aspect of military manufacturing. Prioritize volume while maintaining sufficient quality rather than producing flawless weapons in limited numbers. The United States entered World War II with the largest industrial base in the world, but it expanded dramatically to meet the unprecedented demands of global conflict. Factories originally dedicated to automobile production were rapidly converted to arms manufacture, employing the same labor force, machinery, and assembly line techniques. This industrial flexibility allowed output to surge quickly and be sustained over years of intense demand. Standardization was central to this system. Any part from one manufacturer could be installed in a weapon produced by another. Ammunition, likewise, could be fired in any compatible firearm. This interchangeability simplified logistics and multiplied combat effectiveness as weapons could be maintained, repaired, and replenished without delays. Every soldier equipped with an M1919 or other standardized firearm effectively had access to the collective industrial output of the entire nation. Japanese production philosophy was almost diametrically opposed. The Type 92 heavy machine gun exemplified an approach rooted in traditional military and artisanal values. Its construction emphasized precision and craftsmanship over quantity, reflecting a cultural legacy that prized individual skill and meticulous workmanship. However, this emphasis on perfect fabrication proved incompatible with modern industrialized warfare. The Type 92's elaborate oiling system, rigidly fitted parts, and fragile 30-round feed strips made it prone to failure under battlefield conditions. Its considerable weight further restricted mobility, revealing a failure to recognize the operational realities of mechanized, high-intensity combat. The tactical implications of these differences were profound. American forces were consistently confident in their weapons, a psychological advantage that influenced decision-making and battlefield behavior. Marines and soldiers could hold positions under repeated Japanese attacks, advancing and maneuvering with the assurance that M1919s would provide suppressive fire to neutralize enemy positions. This confidence reinforced aggressive doctrines. Units could seize the initiative because they knew their firepower would dominate the engagement. Japanese forces, by contrast, were acutely aware of the limitations imposed by the Type 92. Their inability to sustain continuous fire against American positions forced them into increasingly desperate tactics. The massed banzai charges seen during the late stages of the Pacific Campaign were a tactical response to this disparity. Unable to compete with American volume of fire, Japanese soldiers sought to close distance rapidly, neutralizing the enemy's advantage in firepower through hand-to-hand combat. While courageous, these tactics resulted in catastrophic casualties and accelerated Japan's defeat. The contrast between American and Japanese industrial approaches extended far beyond small arms.
U.S. forces benefited from a system capable of mass-producing not only weapons, but also ammunition, spare parts, and logistical supplies in virtually unlimited quantities. In Japan, by contrast, the emphasis on artisanal production meant that each weapon required individual attention, unique components, and extensive maintenance. This labor-intensive approach multiplied logistical strain, leaving frontline units increasingly vulnerable to supply shortages and equipment failures.
The tactical consequences were starkly evident on July 7, 1944, during the Battle on Saipan. Massive Japanese infantry assaults collided with American machine gun emplacements. The outcome, however, was no longer in doubt. M1919s could sustain fire at 400 to 600 rounds per minute using 250-round belts, unleashing a continuous torrent of bullets that the Type 92 could not match. Japanese crews, constrained to 30-round strips with a slower rate of reload, were forced into repeated pauses that left them exposed. By simple arithmetic, one M1919 could put 10 times as much lead down range in the same time frame. A single minute of uninterrupted fire from an American machine gun equaled the output of a Type 92 over multiple reloads, demonstrating how industrial scale and mechanical reliability directly translated into battlefield dominance. This combination of production philosophy, logistical planning, and tactical doctrine illustrates why American forces consistently gained the upper hand in Pacific combat. It was not simply superior courage, terrain, or strategy alone, but the systematic integration of industrial capacity, standardization, and firepower that shaped engagements. The M1919 in particular became a symbol of this approach, a weapon whose reliability, ease of operation, and sustained firepower allowed U.S. troops to execute modern combined arms tactics with unprecedented effectiveness, turning raw industrial output into decisive military advantage. Across the vast expanse of the Pacific theater, the advantages conferred by American machine gun firepower were magnified exponentially. In nearly every engagement, from dense jungle skirmishes to coral-strewn beaches, Marine rifle companies and Army infantry battalions possessed the ability to shape the battlefield with sustained automatic fire. M1919s could create interlocking zones of suppression that no Japanese unit could penetrate, allowing American forces to dictate the tempo of combat and impose their will on the enemy. The reliability of the M1919 was a decisive factor in this superiority. These weapons functioned consistently under conditions that would cripple lesser systems: high humidity in tropical jungles, abrasive coral dust on islands, volcanic ash on contested terrain, and torrential monsoon rain. American gunners could count on continuous fire, confident that their equipment would not falter at critical moments. Japanese soldiers, in contrast, faced constant uncertainty with their Type 92 heavy machine guns. The weight, mechanical complexity, and fragile feed systems made these weapons prone to stoppages at exactly the moments when reliability was most crucial, eroding both operational effectiveness and troop morale. Production statistics underscore the scale of this disparity. By the war's end, the United States had manufactured nearly 390,000 M1919s across all variants, while Japan's total Type 92 output barely exceeded 45,000 units. This numerical imbalance extended beyond sheer numbers. American forces had more dependable firearms, a nearly limitless supply of ammunition, standardized spare parts, and crews trained to maintain and operate their weapons efficiently. The cumulative effect of these factors was multiplicative. A single Marine equipped with a Browning machine gun could deliver the suppressive power of several Japanese crews combined. Across thousands of engagements, this differential translated into strategic dominance and shaped the outcome of campaigns throughout the Pacific. The design philosophy of the M1919 reflected a deliberate synergy between engineering precision and mass production pragmatism.
John Moses Browning's simple yet robust mechanism, firing the .30-06 Springfield cartridge at 400 to 600 rounds per minute, emphasized sustained reliability over intricate craftsmanship. This combination of durability, ease of operation, and industrial scalability allowed the weapon to convert firepower into a nearly continuous, repeatable process, a critical advantage against forces relying on slower, maintenance-intensive systems. In contrast, the Type 92, with its finely machined parts, cumbersome oiling system, and restrictive 30-round feed strips, could not maintain comparable rates of fire. Its design, while impressive in peacetime demonstrations, failed to accommodate the chaotic realities of island and jungle combat.
The broader lesson of the Pacific War was clear. In industrialized conflict, sustained automatic fire was as decisive as strategic positioning or troop courage. American doctrine, emphasizing fire volume, crew coordination, and logistical support, allowed M1919 teams to dominate engagements and neutralize numerical disadvantages. Japanese forces, constrained by artisan manufacturing, limited ammunition, and weapons prone to malfunction, were forced into aggressive shock tactics, such as banzai charges, to attempt to close the gap. But these measures often resulted in catastrophic casualties. The Type 92's shortcomings reflected a fundamental misunderstanding of modern warfare's demands, where the ability to maintain continuous, reliable fire dictated battlefield outcomes. Ultimately, the M1919 Browning exemplified how careful engineering paired with industrial capacity could produce a weapon capable of decisively shaping combat. Its enduring legacy demonstrates that in modern conflicts, mastery over firepower through reliability, volume, and logistical sustainability can outweigh individual skill, bravery, or terrain advantage. Across the Pacific, American forces proved this principle repeatedly. Sustained, dependable automatic fire created barriers no human courage alone could overcome, turning mechanical superiority into strategic victory. Japanese infantry armed with Type 92 heavy machine guns consistently faced a significant disadvantage in combat. While these weapons were carefully machined and capable of accurate, deliberate fire, their limited rate of fire and small 30-round feed strips could not contend with the continuous hail of bullets delivered by American M1919s. Each Browning fired between 400 and 600 rounds per minute from extended belts, creating an unbroken curtain of lead, whereas the Type 92 could sustain only around 450 rounds per minute, interrupted repeatedly for reloading. This disparity transformed battles into lethal mathematical equations, with Japanese units paying the ultimate price. Tactics that had previously succeeded against lightly armed or poorly organized enemies, such as the massed banzai charges employed in China, proved catastrophically ineffective against disciplined, well-supplied American forces. Waves of Japanese soldiers attempting to cross fields covered by M1919s were decimated before they could reach friendly lines. The human cost was immense, with thousands perishing in repeated assaults against kill zones created by coordinated automatic fire. The technological and industrial gap translated directly into mortal consequences on the battlefield. The contrast between the weapons also illustrates the broader strategic differences between the two nations. The M1919 symbolized the fusion of practical engineering, mass production, and doctrinal innovation. Its designers prioritized reliability, simplicity, and ease of maintenance over unnecessary precision, producing a weapon that could be operated effectively by minimally trained crews in any environment. Each decision, from ammunition standardization to belt-fed design, reflected a calculated understanding of industrial warfare and its demands. The Type 92, in contrast, embodied the limitations of Japan's approach, a highly refined, labor-intensive weapon optimized for accuracy rather than sustained fire,
reliant on manufacturing processes unsuited for mass production and designed for tactics developed in an earlier era. Every engagement demonstrated the consequences of these philosophies. When American machine guns unleashed their fire on advancing Japanese infantry, the outcome was not merely influenced by courage or morale, it was predetermined by decades of design choices and the capacity to produce weapons at industrial scale. In this sense, the M1919 had already won the logistical and production battles long before the first rounds were fired. By war's end, the numerical advantage was overwhelming. Nearly 390,000 M1919s had been deployed, compared to approximately 45,000 Type 92s, a ratio of almost 9-to-1. This imbalance guaranteed that American forces could apply overwhelming firepower continuously, while Japanese units were forced to conserve ammunition and accept untenable risks. The M1919 success demonstrates that industrial capacity, combined with practical design, can decisively shape warfare. Its sustained fire, reliability under harsh conditions, and mass availability allowed American troops to dominate battles across the Pacific, turning superior production into strategic leverage. The Type 92, by contrast, became a symbol of the limits of artisanal weaponry in an industrial age. Finely made, technically impressive, yet strategically inadequate. In the final analysis, the Pacific War was decided not solely by valor, skill, or bravery, qualities both sides possessed in abundance, but by the ability to field vast numbers of dependable weapons capable of relentless, sustained fire. The story of the M1919 and the Type 92 encapsulates this fundamental truth. Industrialized production and practical engineering determine outcomes in modern warfare, and in that contest, the M1919 was unmatched.
November 20th, 1943, Betio Island, Tarawa Atoll. As dawn broke over the shattered beaches of Red Beach 2, the Marine Corps confronted what would become one of the bloodiest engagements in its history. In the ruined coral and shell-scarred terrain, Corporal William Dean methodically inspected the ammunition belts for his M1919A4 Browning machine gun mounted on its lightweight tripod. 250 rounds of .30-06 Springfield ammunition were prepared for sustained fire. Around him, fellow machine gun crews checked and readied their weapons, the air heavy with smoke, dust, and the tremor of distant artillery. Soon, the first sounds of the Japanese counterattack cut through the morning haze. Waves of enemy soldiers advanced under fire, accompanied by the staccato rhythm of Type 92 heavy machine guns, whose distinctive firing cadence had earned them the nickname Woodpecker. Japanese crews wrestled with their cumbersome 122-pound weapons, feeding 30-round metal strips, while American M1919s unleashed uninterrupted streams of bullets. This encounter exemplified the stark contrast between American and Japanese automatic weapons doctrine. The M1919 Browning, the culmination of John Moses Browning's work, represented a practical synthesis of industrial capability and combat-proven design. Derived from the water-cooled M1917, the air-cooled M1919 fired the powerful .30-06 Springfield cartridge at rates of 400 to 600 rounds per minute from belts holding 250 rounds or more. Each 150-grain bullet exited the 24-inch barrel at approximately 2,800 feet per second, delivering lethal energy over 1,500 yards. Engineered for battlefield practicality, the M1919 system weighed only 45 pounds with tripod, allowing two Marines to transport, deploy, and operate it effectively. Its relatively generous mechanical tolerances, once criticized for reducing precision, were actually an advantage in the Pacific. Sand, mud, carbon buildup, and humidity interfered little with operation. Training was straightforward. Even minimally experienced Marines could master the recoil-operated mechanism in a short period, yet the gun was capable of firing thousands of rounds reliably. By 1944, American industry had produced nearly 390,000 M1919s across multiple variants. Production was distributed to ensure resilience. General Motors' Saginaw Steering Gear Division alone manufactured over 200,000 units, with Rock Island Arsenal and Buffalo Arms Corporation supplying tens of thousands more. This industrial scale guaranteed that American forces maintained standardized, dependable automatic firepower across the Pacific Theater. The U.S. Marine Corps deployed M1919A4s at the company level, typically with 2 guns assigned to the weapons platoon. By 1945, Marine divisions could field hundreds of these weapons, creating overlapping fields of fire capable of devastating enemy infantry assaults. By contrast, the Japanese Type 92 heavy machine gun exemplified a different design philosophy. Adopted in 1932, the 2592nd year of the Japanese imperial calendar, the Type 92 was an air-cooled, gas-operated adaptation of the French Hotkish. It fired the 7.7 by 58 mm semi-rimmed cartridge from 30-round metal strips at roughly 450 rounds per minute. While a step up from earlier Japanese weapons, the Type 92 had critical limitations that undermined its combat effectiveness. The 30-round strip feed drastically limited sustained fire, forcing crews to reload frequently in the heat of battle.